In the summer of 2024, 12 of the greatest minds in the history of video game development, design, and theory gathered in the woods of Southern Oregon to discuss the modern gaming industry and the emergence of artificial intelligence technology. This is a series of conversations between old friends, old men now, men who have shaped the gaming world as we know it today, and whose innovations will continue to influence how we play for generations to come. Episode 6, The Limitations of Limited Language Models.
Today, our primary topic is going to be the limited language model AIs, because there seems to be a very strong consensus that these are going to have a revolutionary effect on our industry. And the questions really are how, and especially how quickly, those effects will take place. And so I would like to start the discussion with some, since everybody seems so positive about it, I thought, okay, I got to throw in the negative stuff. And so I have some observations here about two fundamental limitations. Actually, first, I'd like to point out that the limited language models we're using now are merely grand versions of technology that's been around for a while. This is Markov chain stuff. And back in '89, I think, I did a game called Guns and Butter, and I used what would now be called generative AI at about, that level to create the names of continents and provinces in the thing. I had a database of about 150 Mongol names, and it went through and it did the same thing with them to create these really good sounding exotic foreign names. It worked only because Mongol Turkic languages are so exotic compared to our Indo-European stuff that people could look at some of these things and say, oh yeah, that looks realistic, even though it was real crap. So anyway, this technology has been around for a while, and what has changed is the magnitude with which they're doing it at a gigantic scale, and it really works when you do it on a big scale. However, we have to remember these are limited language modules, and the Markov chain only works with text. That is, the way it does the calculations of probabilities, it's great with text. But they've gotten very clever about applying it to images and voice and music and everything else. But the trick that is often forgotten is that in order for that to work, you got to tag stuff. And that's the expense of creating these huge things. And the tagging process is especially difficult. They have to, they have these peons in Tanzania who, bicycle, wheel, handlebars, and so forth. Now, here's the problem. Some things are easily tagged, nothing is easily tagged except words, but there is a sequence of stuff. It gets harder and harder to come up with good tags. So if you've got images, for example, especially of physical objects, those are pretty easy to tag because you're only talking about a few score tags necessary to really pretty well define what something looks like. For things like Midjourney, they're obviously putting more tags in there. They're getting better with image tagging. But as you move up that scale, the number of dimensions required to specify something increases dramatically. And I want to point out that this is a killer problem with character types. Consider Luke Skywalker, Neo, and Frodo Baggins. 3 characters. They're the same character. This is the hero's journey. They're all doing exactly the same thing. But think about all the words you'd have to use to really clearly differentiate each of these from the others. We're talking about a huge tagging problem. And so the first obstacle I want to point to is that, or warn you about, is that as we get up to these higher level problems, the tagging problem will become a killer. I really doubt that we will be able to come up with good tagging systems to define characters, and that means that the AI technology probably won't allow us to do good interactive storytelling. The other major obstacle, let me check my notes. I was scribbling here. Yeah. Oh, yes. In fact, let me point out, it takes an entire story to define a character. You really don't know Luke Skywalker until you've seen the whole movie, the first movie. And in fact, even then you don't really know him. It takes more movies, you get a better characterization. Neo, same way. He is really the classic hero's journey. And, that moment when he stands up and looks down the hall at the agents and sees the numbers coming down. Boy, that's the classic hero's journey success. But even then, in future movies, we get deeper into his character. And so if you wanted to somehow reproduce him in AI, you'd need to somehow absorb all of those things. And a similar problem with facial expressions. Facial expressions at a simple level really are easy to do. A lady at Atari Corporate Research, Susan Brennan, I think, she did something way back in the late 70s with faces. She did something that could allow, by reducing a face to line drawings, she had a system that allowed one face to transform into another person's face, and you could get halfway between Adolf Hitler and Donald Trump or whatever. So you could, and I use that technology for facial expression stuff, basically reducing a face to a bunch of points with lines between them, and then you just move the points around, and you can get some pretty good facial expressions with that simple technology. However, if we really want to do it right, we've taken faces to the photorealistic level, but the emotional content of those faces is crap. We don't know how to make those faces, how to give a real human expression. And that's because, again, the number of dimensions you need to really specify a facial expression is enormous. And that's what differentiates a mediocre actor from a great actor. The great actor has just these tiny differences in the muscles that make an expression hit home. I saw a wonderful YouTube video about Andy Serkis and his the recent monkey movie. What was it called?
Monkeys.
Yeah. Where they do a flashback to him, and the video was about just one facial expression thing. Kathy, do you need to? No. Okay. He had. It was a flashback to a place where he was confronting a very evil human colonel, I think, who had really committed horrible war crimes against the simians, and he hated this guy with, at a very deep level. But the guy was telling him, "Oh yeah, but your people did this to my people," and he was explaining his personal experiences. And it turned out that he had suffered enormously too, and he had been the victim of some very serious moral outrages. And Circus had like 10 or 15 seconds, and the commentator said he just did 3 things with his eyes. His face itself did not move much. It was almost entirely the eyes. First, he stared almost blankly at the colonel. It was the shock of realizing, my God, this guy suffered too. And then he sort of looked to one side thinking, my people have done these horrible things too. And then finally he looked downwards, obviously thinking, have I terribly misjudged this situation? And you could watch that sequence, and it was loud and clear what he was thinking. And it was just the way he moved his eyes. And so the commentator was observing, this is great acting. There's no way we're going to capture that in any AI in the foreseeable future. This is definitely far future stuff. Another thing I'll point out is that facial expressions are complex in another way. Do you know what microexpressions are? The little tiny things that flash across the face. But there is another complexity, and that is mobile expression. Actually, I've seen several terms for these. The idea being, best example, sometime if you can pull out the movie Shrek, there's a really blatant example of this. The scene where they suddenly discover that Shrek has an arrow in his butt. And the princess tells the donkey, go off and find this flower. And then she says, I got to pull it out of your butt. And she reaches for it, and oh, no. And so they go through this thing with her trying to get the arrow away from him. And they fall over each other, and she's lying on top of them when Donkey comes back and says, oh, geez, if you guys need some time alone, you just tell me. And she jumps off of him, and he says, oh, God, no, I would never. I mean, romance, yeah. And all of a sudden, she grabs the arrow and yanks it out of his butt, and he goes, ah! And he turns and looks at her, and that's the facial expression. She holds it up and just waves it a little bit, and her facial expression changes as she does it, and it's the change that gives it power. And yet this is animation. This is not an actor. These are really good animators. So anyway, my point here is, do not underestimate the complexity of human facial expressions. They are. Another indicator of that of how complex they are is how important they are, because they have done experiments showing that babies, 5 days old, can differentiate a smile from a frown. So this important stuff. Anyway,
Another great example in the just released Inside Out 2.
Oh yeah, I want to see that.
This isn't really a spoiler. There's a scene very close to the beginning. Three girls, the main character and 2 friends of hers in a car, and they're sort of having a fight. And so inside, the characters inside her head, inside Riley's head, are dissecting, what's going on. And they're like saying, oh no, this friend is feeling this and this friend is feeling that. And they're like zooming in on their facial expressions and saying, look at the eyebrow, and like replaying it and like, see how that eyebrow like arched a little,
Oh,
that means she's thinking this. And they're arguing about all of the meanings of these very, very small, faithful difference.
Yeah, exactly.
yeah.
Wonderful.
Yeah, I got to see that movie. The first one was great also. So the second major problem is the knowledge base required. I think people underestimate the amount of knowledge that goes into human behavior. Consider the database used for consider the knowledge database goes into any of the AI systems, of the millions of images, the petabytes of text, and so forth. That's a lot of data. Compare it with the total amount of data in your head comprising your life. Everything you know. It completely dwarfs. I mean, the stuff in the computer is microscopic in comparison to that. And in order for the computer to understand things, it's got to know everything. For example, imagine 30 years ago, my wife and I are talking, and I mention a problem, and she looks at me and says, "Frankly, my dear, I don't give a damn." Okay, to understand that, you got to know about that movie that was, 40 years earlier. And in fact, you got to know the whole movie so that you can understand what that means. And, wait a minute, though. You got to take into account her vocal intonation, the way she says it, a little bit of sarcasm there. That puts it in a completely different light.
Meretzky used to call that context. I mean,
yeah,
he thought that was the biggest challenge in AI, with context.
Yep.
So what I've seen with LLMs is they've tried to solve context by throwing data at it, essentially.
Yeah.
And that's the current approach.
Yeah.
I think there's an intellectual property thing going on here that I think is just about as important as anything else, which is, if you're going to train these LLMs, you have to have that data. And in many cases, especially the GPT implementation so far, to be honest, those are copyright violations.
Oh, yeah.
Top to bottom.
Especially when people quote a song or, our lives are full of contextual references to things that are copyright.
I would say it's the latest incarnation of, I think Napster is probably the first incarnation of this.
Yeah.
It's what I would call the criminal corporate model.
Yeah.
So Amazon was a version of it, frankly, when they wouldn't pay taxes. Uber is a version of it when they essentially violated all the cab laws in every fucking city that they went into. It seems to be a method nowadays to decide what law can I kind of break that I can get away with long enough to establish enough market position that I can resolve it later. And the AI guys seem to be following. The difference is, in those other cases, the victim group was limited. It was always a small group that they could basically isolate. And the answer is, right now, the victim group is everybody. Meaning, Zuckerberg believes he's going to feed everything he's ever heard from any one of us in the world of Facebook, true or not, by the way, into his systems to make his systems advantageous for others. Yeah. And the simple fact is, no, you shouldn't be, because we didn't grant you those rights for those reasons. And you shouldn't have the rights to do that. You will not get to do that in Europe. That's my judgment.
But these systems are so opaque. It's impossible.
Yeah. I think the burden of proof is going to move to those guys who have to prove what their training system was, which means the process of training these things is going to become a very interesting industry over the next 10 years, just for the legal and intellectual property.
I think there would be one big mistake. I see that same trend because there's big money that has a lot to lose that either has to fight now. There's not another good line to fall back to, so they have to fight now.
I don't disagree. My point is, I think there may be a round where many of the current models today will actually have to be discarded based on their legal.
Well, you can do like white room development techniques, right? Where you can prove, here's the data that came in, everything, so that's doable.
With the process, and then you're clean.
Well, exactly.
That's probably as
Adobe is opt-in, and they pay people, so that's going to be a clean deal.
There's a solution there, right?
Yeah,
Right.
I'd like to solution. But my point has been that we have trained a generation of entrepreneurs to break.
Yeah.
And this is a place where the scale of that law breaking is epic.
I'd like to interrupt and let Sid have an opportunity. Let's hear Sid's opinion.
Fascinating. Frankly, this is something that I have kind of almost ignored. I mean, my vision of AI goes back to CPU box, and I've always written the AI for all my games and found it fun, but it's very much concrete, logic, code. This idea of scraping masses of data and magically something appears out of it is, potentially amazing. What's kind of fascinating to me about it is that we don't really know how we get from point A to point B, and I guess what comes to me first though is the uncanny valley idea. Like, are we amazed by this because the horse can, count to 3, or is it something really totally amazing? I guess that's my question. Is it amazing because it's surprisingly unexpected, or is it truly amazing?
Well, why don't we vote on that? Just as a
Well, I haven't. Oh, amazing.
just amazing.
Oh, yeah. Okay.
Who here thinks their experience with LLMs is amazing? I'm pretty cynical.
Every hand went up.
I didn't.
Yeah.
I got a comment on that. My first industry job in 1980, a friend of mine, a guy named Bob Harris, who made some games that unfortunately are pretty obscure. He was playing around with it and said, "What if I feed in some data to the computer that's just text?" From he started with a Snyder's Pretzels back of the box story of how Snyder's Pretzels started, and look at combinations of letters, because this was 1980s, and say for like 4 or 5 letters in a row, what's the probability of the next letter?
Yeah.
And basically do it that way. And he had they're up and running, and we thought, well, okay. And it was kind of garbled, and until you got to 5 or 6 letters, there were a lot of things that weren't real words or that were combinations, and you got little loops of words that had multiple sections that sort of repeated all that. And yet, when he fed in the Snyder's Pretzel thing, and it then generated random text based on that thing, it was eerily, familiar. And he did some Shakespeare stuff, and it's like, wow, there's really something there. But it was just garbled stuff. And when I first heard about ChatGPT 3, I knew people had been playing with this sort of thing, but it just brought me back suddenly to 1980 and realizing, I think it's sort of in support of what Sid's saying here, and that on some level, we as humans obviously we all know that people will find patterns even when there aren't any.
Yeah.
But this is something where it's progressed to the point, kind of just by brute force, that there are these patterns that on the one hand seem like, oh yeah, it's just a trick. It's the horse counting to 3, and we're just amazed it does it at all. And on the other hand, it starts to make me wonder just how much of what we do in our heads is not all that different. And what you were saying, about Chris, about the how much is stored in our head. The more we know about how it's stored, the more we realize that evolution takes all sorts of weird shortcuts, and that's why we have so many arguments about what was really happening. And it makes me wonder, as has happened in our backgrounds a lot, how much computers are just reproducing some of what biology has been doing, and that's why we're so excited about it.
Yeah, can you prove to me that, the way I'm reading your emotions right now is true? You can't prove it to me, right? When 2001 came out, it was interesting. That's what really got me kind of interested in AI and computers and all that. The space stuff was cool too, but HAL was the really interesting part. But people came out of the theater, after seeing HAL and saying, there's no way he'd beat the guy at chess. And the fact you would have natural conversations and just people and all, of course they'll do that, but they can't play chess. It requires intelligence, right? And so these AIs, and back then, like in the 70s, the AI researchers were trying these procedural approaches. I'm going to do it all in code, have all these, expert systems, sets of rules that will define the way my AI works. But there was a whole another group of people saying, no, we just have to wait for Moore's Law to catch up, which it has. And, it took that long for Moore's Law to catch up. And they were saying it does require brute force because current LLMs they're indexing data across billions, and this is not an exaggeration, billions of dimensions.
Yeah.
All right. Which is something we can't even really conceive of. So there is something going on here. It's not that horse counting the three for sure. And I think the distinction Chris made at the very beginning, right now we're talking about LLMs, language. There's so much more to AI than just language.
Yes.
And I think that's where a lot of the really interesting applications are going to be. Right now, language is an easy data set for us to scrape. But, Tesla's been doing this with their fleet learning, where one car learns from all the other cars. There's so many applications of this in the areas that are really important to us, And, if Andy Serkis can learn to simulate these emotions, or even an animator can learn to animate Fiora that accurately, I am not convinced that a computer can't learn to do the same thing.
It's okay.
Yeah, so, Chris, a couple of things. So, Rich is right, and both in we've rewarded rule breaking to a major extent, like massive rewards for minor rule breaking, and now we're doing massive rule breaking, hoping to get massive rewards. The legal stuff, the thing that scared me off of LLMs for my own, for the work that I'm doing, is the legal problem. I just see it's 10 years to work that shit out in court. And the fact is that they were fast and loose across the board. So the only application that I see for an LLM is one that I train myself with data that I absolutely know the source of and can verify to make sure that I'm not going to get screwed down the road. Because in the end, the legal system wins somehow, which means the lawyers, not us.
Or the politicians.
Right. Or they buy the politicians and change the legal system.
I'd like to it's it's always my role to be the devil's advocate. I'm on salary from Satan, and
That's a t-shirt.
yeah,
That's a fashion deal.
yeah, very likely. Let me point out on the complaints about the misuse of stuff. Let's differentiate between copyright and use right. That is, copyright is the right to make copies, and our laws only address that because that was the only real issue when printing got started, and we had hundreds of years, and it was only with printing, and so the copyright laws were very clear and easy to apply. And then, radio, TV, cinema, so forth, it was easy to extend the copyright laws for that. There were some issues, but that's completely different from use right, because in fact, people have been using other people's artistic expressions for generations. It was fundamental to every artist for, at least 500 years. You had to go through the various collections of paintings and look at everyone and maybe even make copies. That was a fundamental part of an artist's training. Musicians, you don't learn music by just screwing around. You got to listen to a lot of other music and say, hey, I never thought of doing it that way. Literature, every novelist, you've got to read thousands of pieces of fiction before you can become a good writer. So usage right is, we ethically concede that usage right is free. There's absolutely no restriction on it. And so now we get into this issue with the LLMs where they're not really copying in the sense of copying and delivering to somebody else. They're looking at it and learning from it. They are using it. So I would argue that in the strict sense, they are within society, within the law, within society's definition.
I don't agree, and I can make my case for why it's not.
By all means.
So if I take Paul's Led Zeppelin vinyl and I copy it onto my computer as a raw AIF file,
yeah,
and then I convert it to an MP3 file, there is no physical relationship between the original expression on that vinyl and the MP3 file I had, because it's been through two levels of abstraction to get there. That being said, that MP3 file is still currently considered under U.S. copyright law to be a copy of that.
Yeah.
Thank you, Napster. for clarifying that. And so what I would say is what I see currently being done with training of large language systems seems a lot more like making an MP3 file out of it than reading the book to gain greater wisdom.
I disagree on the argument that. Okay, go ahead.
Well, no, yeah, I don't. So there was one argument like if I take a Picasso and I put it in my Xerox machine, and out comes just it fails. Have I infringed its copyright? And the answer is really no, because it doesn't look anything like it.
Yeah, I mean, why that MP3 is judged to be a copyright violation is because
it sounds like
because an end user can't distinguish.
Yeah, that's the key.
Right.
Yeah.
So to me, just to drill down a little bit more on that, so that's why I think you have to be careful making the analogy. If it sounds exactly like it.
Well, I picked Led Zeppelin on purpose. Those of us who lived through the early days of MP3 realized that the one thing MP3 1.0 did really a shitty job was of Led Zeppelin guitars. So as a result, all MP3s of Led Zeppelin to me were extremely distinguishable.
Yeah, but if you play your MP3 and a person says, hey, it sounds like a record that Paul has, that's the test.
I wanted to add just 2 points. One, I was going to repeat from yesterday, just because we lost that, which is always, I try to make sure we're thinking about what we want not to be true, okay, because it just offends us in some way versus the reality of what's happening. So some of the things in the progress in terms of, let's talk about facial expressions, for us that have been working with this stuff for the last year and a half, the exponential rate that it's growing is amazing. So I think you'll be disappointed in how it's going to solve a lot of those things. They're neural networks. They're not just copying.
Yeah.
And they're the first ones to admit we don't quite know what's going on down there. Right.
Yeah.
And now you're gonna put quantum computing together with it. And they're really not going to they're going to send it in and out. What comes, we don't know what happened. And so I think it's more than just copying, predicting the next word. These are neural networks. They're doing beyond that. So I think it's worth thinking about that as we frame this.
So if an artist, if a painter, say, does his interpretation of the Mona Lisa, paints another Mona Lisa, but he created it.
Right.
He's violating copyright, if it were copyrighted.
Well, maybe.
I mean, he's doing the same thing.
I think Paul has a point.
Yeah, sorry. Yep.
Sorry.
Let me the way there's some analogies that already exist. So if you copy, a big section of a composition, you've broken the copyrights. If you copy a small section of a composition, you have it. And I'm the first to admit I don't totally understand how these work, and I haven't built my own databases. But in using them, I haven't seen a recognizable piece of a composition. I've seen things that look original to me, and I've done Google searches trying to find sections of them in the online database of images. So I think if what we're saying is it legal to read, absorb, and process a million compositions and then generate from that a new composition, or say I want a composition that leans like this or like this based on tags, at least on the argument you were describing, I don't think we are producing copywritten material. Now, I know that we're going to end up taking jobs away, or LLMs will end up taking jobs away from a large class of beginner or early learning artists. And that's a problem. But I don't think you should conflate that social problem with the technical or legal problem. I do agree, though, ultimately, the laws will end up being
Thirdly, or let's be clear, there's a third legal route, which you touched on accidentally, I think. So what you're saying is what you currently see is not a trademark violation, a copyright violation. But in fact, here's the interesting question is, the material, the product that they produce may in some cases not be copyrightable because of the source. So you may see the legal solution here be that it isn't a copyright violation, but you cannot protect the output with a copyright.
Join us next as Episode 7 shifts to the potential applications of AI in game design and creative industries.